Today we're going to talk about loops, and we're flexible with the phase, but we'll try to do all type of loops today, or better, like the main ones, because there are like so many. So if we can do everything today, next time we'll focus only on practice. So as I was saying before, this one, it's not an easy class, so don't worry if you feel confused. It's totally normal. It takes some time to get used to the logic of all the type of loops. So from last class, just very quickly to give some context, we discussed about the logical operators, so the and, or, greater than, smaller than, and we introduced the if, else if, and else statements. And we are gonna do also some practice with some of this previous knowledge. Okay, so let's focus on loops. So I found this nice video on YouTube that explains what a loop is, because there are so many different type of loops. And let's see.
I'm Sarah from Codecademy, and today we're going to talk about a fundamental concept in computer science: loops. Life, like programming, is full of repeating routines and subroutines. Every day we wake up and brush our teeth. We don't just brush one tooth, we brush each tooth in our mouth until we've brushed all of our teeth. In programming, when we know we're going to use a routine again, it's good practice to put that routine into a function so that we can reuse it. When we want to repeat a function or subroutine multiple times in a row, we can use loops. The other day, I wrote some instructions for frosting a cupcake and put them in a handy function, frost cupcakes, so that I could reuse them whenever I needed. Say I need to frost 3 cupcakes in a row. Okay, no problem. I can just call my function 3 times, right? But what if I needed to frost 5, 10, or even 1,000 cupcakes? Here's where a loop saves the day. A loop allows you to continually execute the same code multiple times, or loop through a routine, until a stopping condition is met. There are different types of loops, and each programming language has their own syntax. But all loops have one thing in common: a stopping condition. This condition is checked every round, and the loop will continue to run until the condition is reached. If our goal was to frost 4 cupcakes, the loop stopping condition would specify to continue to frost cupcakes until 4 cupcakes have been frosted. So our loop would run frost cupcakes 4 times, giving us 4 fully frosted cupcakes. Loops allow us to tell the computer where to start and provide a condition upon which to stop, all in a few easy-to-read lines of code, which is super sweet.
So last time, I don't know if you both tried this exercise in my emotion projects. Did you? Give me a yes. Okay, Rosie, don't worry. So if you try this exercise, there was something kind of like that was not really working super well, because let's try to do it together. So this exercise said, it was based on the if-else statement. So write an if-else statement only for anger. We had like the anger variable stored here. So how useful is sorry, how useful is anger from a 0 to 100, and we have like, I think something like 212 participants, something like that. So the exercise asks you write an if-else statement only for anger that says, if the participant score is less than 30, display anger is not very useful. If it's between 31 and 17, then display anger is useful, else display anger is very useful. So let's start to do it. So if anger is less than 30, then display anger is not very useful. I'm not reading it all, but that's the concept. Else, if angus less than 70, then display else useful, and then we end. So if we do that, let's try to run it here. The only result, you can see the results here because that's the live script. The only result that gives you is very useful, which is actually not a very useful result because it gives you the results of only the first participant. And actually, you would like to know for every participant if it's like anger was useful or not. And so what do? We have to wrap this if else statement in a for loop, which is the first loop we're gonna gonna see today. So this is gonna be for the index from 1 to the length of anger useful. No, sorry, yeah, anger useful. Each participant equal anger use, and then we use this index inside anger useful to actually extract the value. And then we put the end at the end here to close the for loop. Now here we have to replace this ang use with the each participant, of course. And here as well. And it should work. Let's see. Here you go. And so for each participant, you have the score and if it's useful or not, which is exactly what we wanted. So that's basically what we just seen live. So just to make it explicit, the for loop start with an index in the array, and you set up the starting point and the final point. Now you can just for example, and then you give a command and then you finish the loop. So you can if you don't know the length, or if you want to have it like a flexible loop, you can just put like a length, the length command, and then the array inside the brackets, or you can just set up a number here. So here, what will the for loop display? That's pretty clear. So index from 1 to 10 is going to display 1, 2, 3 up to 10. From 1 to 2, 1 and 2. But now, what if we want to actually extract the values inside the vector? We have to like use this index to extract the values, to see the position inside the vector, and so extract the values. So in this case, it's going to be length of the vector, and then like vector with the index inside the brackets. And then here the answer is not going to be 1, 2, 3, but it's going to be 2, 4, 6. If we just display index like that, then here the answer would have been 1, 2, 3. Let's make it a little bit more complicated. Now we talk about the nested for loop. So the logic is exactly the same. Have you ever watched the movie Inceptions? No, Rosie, no, you have to watch it. It's an amazing movie. Anyway, the logic is the same. So it's like having a dream inside a dream. So just remember that it's very important to keep a nice indentation, because otherwise it's going to be messy and you're not going to understand which part of the loop it's where and all this type of stuff. So in this case, it's like you double loop. So for I from 1 to n, and then for j from 1 to m, do something and end. We're going to see some examples, don't worry. And so that's basically the general logic. We're not going to watch this video, but I think it's a nice summary about for loops and nested for loops. So in case you want to watch it at home later, it's a good resource. So let's try to do some practice. Just stop at the part 2 because the part 2 is about the while loop. Okay, so let's just start from the beginning. Here we just have to we want to display this figure 5 times, so we just wrap this histogram in the for loops, and then we have 1. And if I can move it, we also have the other 5, but now it got stuck and it doesn't move. But you can see that there are others here. Yeah, but sometimes there are, and now everything got stuck because of the zoom. Okay, perfect. I'm closing them. Okay. Then this other one, we just want to display the index. So just like that. And then the results should be numbers from 1 to 10. Here you go. And then here, we want to add 1 to the index and then suppress the output with the semicolon. So what do I do here?
Is it just index plus 1?
Yeah, that's right. Just like that. And then we can suppress the output or no. Here we have it asks to suppress the output. If we don't suppress the output, we can actually see what happened. Which is like instead of from 1 to 5, it's going to be 2, 3, 4, 5, 6. Okay, here, insert here the length of A to establish the extension, the length of the loop. So the first thing is like from 1 to the length, and then display not the index, like the first couple of exercise, but each element of A. Do you remember how to do it? We have to like use the index to access the position of the elements in A.
Wouldn't we have to name it A and not age?
Oh, yes. Was why I said A? I don't know. It's actually H. You're right. Because the A is on the vector below, I think, or some vector. I don't know. Good call. First of all, let's run this vector. Okay.
So would it be like each element or index each element?
Yeah. How do we do it?
Like, would it just be like similar to, so like ID or I equals each element equals age in parentheses I?
Okay, let's try. So you said each element equal, you said age, and then like that, right? Let's see if it works. And it works. Nice. Yes, that was the... if you don't have to reuse the information just to loop through it, you don't need to assign the variable. So you can just run it like that, and it works exactly the same way. But if you need to reuse this information, then it's better to like store it into a variable. Okay, now it gets more complicated. So this is an example of a little bit more complex code. First of all, we have 3 vectors, vector A, B, and C. This one we already know that suppress the output. Now, when there is a list of vectors, you use this like funny brackets here. That I'm not sure like of the name, but we'll call it funny brackets for the sake of simplicity for me. When you use these brackets, it means that even in the for loop, when you access this like list of vectors, then you need to access it with these brackets. In fact, like the index here, it's not gonna be contained into the normal brackets, but you have to use these special brackets here. So that's an important thing to remember. And here we create an empty list where we are gonna add some elements in the future. So we're gonna fill this empty list using this for loop here. And here we want to put the mean of for each vector, so one mean for each vector. So it's going to be stored 3 elements, so the mean of vector A, of vector B, and of vector C. So first thing with the for loop, we that starts from 1 up to the length of the list of vectors, which is 3, because 1, 2, and 3. Then we access each element of the list of vector. So vector A, vector B, and vector C, and we store it into the variable vec. And then we calculate the mean of each vector, and we store this value in the mean vec. After that, we want to append this result into this 3 vectors mean list. So you have to rewrite it like that: 3 vectors mean equal 3 vectors mean, and then comma mean vec. If you don't do that, if you just do like append it like that with the mean vec and nothing else, you don't store all 3 values. You know what happened? Do you have some idea? Actually, we can try. Let's try. It's the best way. So instead of doing that, we'll just do that. So 3 mean vectors, 3 vectors mean contain only one value, because where am I? Sorry. Because basically this value keeps being changed with the loop, so it doesn't store it. You need to use like this syntax. In this way, you can store at the end all 3 values. Okay. So this exercise, it's very similar to the previous one. The only difference is that you have to calculate the standard deviation. So do you want to try to tell me what to do, and I'll just follow you?
So to create the empty list, you would just do the not funny brackets.
Which one? Which brackets?
It's not the squiggle one, just like the regular bracket.
This one, you mean?
No, like
this one, you mean?
Yeah.
The square brackets. Yes, perfect. Okay, then we have to, from 1 to the length of the number of elements of the list of vector. So what do I do here? From 1?
Yeah, and then you do the colon,
Okay.
length, and in parentheses, list of vectors.
Okay. Now, accessing each of the 3 vectors in the list, use the index I.
So it would be I equals, or vector equals list of vectors I.
Like that?
Yeah.
Okay. Rosie, do you?
Or, no.
Okay.
It's the squiggly lines.
This one? Where is it? This one?
Yeah.
Okay. Nice. That's DT. Okay.
Of vectors.
Nice.
And then you have to do the square bracket of the 3 vectors SD, comma, standard underscore div.
Okay. And let's see if it works. Okay, it was a lie. Oh, because it's SD. Okay. Okay. That's my fault. Nice. It works. Okay. Now it gets interesting. Rosie, do you want to try to guide me?
Sure.
That's unfair because there was not the previous example, I know, but no worries. Let's read the title for create a nested for loops that calculates the amount of interest earned within 7 years if the monthly interest amount is 1%. So here we have first for loop and then the second for loop. Oh my gosh. Okay. For loop that refers to the months. So let's remember these.
Okay. Should we just make the 7 years into months then too?
No, I think we can keep like 7 years. Just we have to remember that 1 year is 12 months for the second for loop.
Okay. So start the for loop looping through the years.
So I equal
Just 1 colon and then 7.
okay. And then loop through the months. So
I guess I equals 84.
so we already looped through the years. So here we just have to loop through 12 months because it's like in order to loop through the years, we just have to tell, hey, we loop through these 12 months and then we have to repeat these 12 months 7 times, basically.
So it'd be 1 through 1 colon 12.
And now calculate the interest increase. So the interest increase, that's just the formula.
0, 1.
0, 1, okay. And then end the 2 loops. And then let's remember to end both. And then we have to print the interest.
At the end, why did you just put interest?
Oh, to print it.
Okay.
Oh, is it just like at the end it's going to say what the interest is?
Yeah. Let's see. Oh, it's 0. There is something weird here. What happened? Does anyone have some hypothesis of why the results it's I mean we are still poor?
Because in the interest underscore increase, you're multiplying the balance by 0.001. You're not doing anything to the interest. There's no like statement that the interest would increase.
Interest. So we actually changed the interest. Is that what you mean?
Yeah.
Yeah, that makes sense. So let's see if it works now. It seems to work, but there is something here that we did that normally we try to avoid, is that calling we have 2 for loops and we call the index with the same name. And I'm not sure if it generates problem in this for loop, but it can generate problems with more complex for loops for sure. So in general, we should do that. And let's see if the result is different or not.
Or could you just do it where instead of doing a nested for loop, I understand why we did it now to learn how to use it, but couldn't you just in general have done like 1 to 84?
Probably. Yeah, that's just for the sake of the exercise.
But yeah, that makes sense.
Nice. So that's all the exercise of part 1.